Okay, so good morning, everyone. For today's video, we will be talking about the logarithmic function. Given the definition, the logarithmic function to the base b, where b is greater than 0 and b is equal to 1, is defined by this form. The log of y to the base b is equal to x if and only if b raised to x is equal to y, for b is greater than 0 and b is not equal to 1. The first form in here is what we call the logarithmic form, and the second one in here is what we call the exponential form. Now, the exponential form can be used in solving logarithmic functions, equations, or inequalities. But you have to remember that your base in here, no, the base in here are greater than 0. However, it cannot be equal to 1. So it could be 1/2, 2, 3, 4, 5, and so on. As long as it's greater than 0, it's not negative and it's not equal to 1. So first, we will tackle how to convert exponential form to logarithmic form. We have here a few examples. We have 5 examples in here. Okay, for a while. We have 5 examples in here, and all you have to do is to remember that the logarithmic of a number is an exponent. So all of these examples in here are given in an exponential form, which is basically from this one. Y is equal to b raised to x. Y is the number, b is the base, and x is the exponent. So our task in here is to move this one into this form. We have the log of y to the base b is equal to x. So this is our aim in here. And remember, the logarithm of a number is an exponent. So given that our number is 16 in here, which is equal to 4 squared, now our base will remain the same. So to convert this one into a logarithmic form, you first have to write down the log of our number, which is 16, to the base 4 is equal to our exponent, which is 2. This will be the same in the following examples. No? So the exponent will always be on the other side. Next, x is equal to 3 squared. So you write down the log of our number, which is x. So log of x, our base, that remains the same, to the base 3, which is equal to our exponent, that is 2. Now, moving on to the next number, 81 is equal to 3 raised to x. We will convert this one into its logarithmic form. So you have to write down the log of our number, which is 81 to the base 3. So you write down this one. This will become a subscript of our log. And then you equate that one to our exponent, which is x. Next, we have 10 raised to negative 2 is equal to 0.01. To convert this one into its logarithmic form, we have to write down first the log of our number, which is 0.01. So we have log of 0.01 to the base of 10, which is equal to our exponent, negative 2. Now, to the next number, we have e raised to y is equal to 9. So you write down the log of our number 9 to the base e is just equal to y. Or if you will get confused, I will be giving you another way to convert this one into its exponential form. So number one is you have to identify, okay? Identify your base, your x, and your y. Okay, number two is your right log, and substitute, okay, substitute the values of your b, x, and y. Okay, say for example, this one, number one, we have 16 is equal to 4 squared. And take note, this is taken from the form y is equal to b raised to x. So I will be putting this one above, okay, for a while. We have The form is y is equal to b raised to x, and we have our example 16 is equal to 4 squared. So step number one, you identify your b, your x, and your y. Okay, in this case, our y, that is 16. Our base, that is 4. Our x, or the exponent, that is 2. Now, after you identify their values, all you have to do is to substitute it to this form. We have the log of y to the base b is equal to x. So copy the symbol or the notation log. You substitute the value of y, which is 16. You substitute the value of b, which is 4. And you substitute the value of x, which is 2. Simple as that. You can choose either way. All you have to remember that the logarithm of a number is an exponent, so that means the other side will always be your exponent. Now let's move to the other way around. You have to convert logarithmic form to its exponential form. We have the following examples: 1, 2, 3, 4, and 5. And we have a note in here: the logarithm is the exponent. The logarithm is the exponent. So these examples are generally from the form log, okay, log of y to the base b is equal to x. And we will convert this one to its exponential form, which will be y is equal to b raised to x. Okay, so in this case, we have y is equal to b raised to x. We have the number, which is y, so that is 16, is equal to our base, 2, and then our x, that's 4. No? So 16 is just equal to 2 raised to 4. Why? Because if you are to evaluate 2 raised to 4, that's just 2 times 2 times 2 times 2, which is equal to 4. So I will be erasing this one. Next, we have the log of 1 over 9 to the base 3 is equal to negative 2. So our number here, or the log, that is 1 over 9. We have our base, that is 3. And then we have our x, okay, that is negative 2. So if you are to evaluate 3 raised to negative 2, that is just equal to 1 over 9. So for example, we have 3 raised to negative 2. Going back to the previous rules that we have discussed, you take the all right, for a while. You take the reciprocal of 3, that is just equal to 1/3, and then you change the exponent from negative to positive. So simplifying this one, we have 1 times 1, and we have 3 times 3. That gives us 1 over 9, which is basically the same on the left side of our equation. So same as that. Next, we have here, for a while. We have in here the log of 1 to the base of 4 is equal to 0. So our log in here is 1. The number, rather, is 1. You equate that 1 to our base, which is 4, and the exponent is 0, because 4 raised to 0 is just equal to 1. Any number raised to 0, that will be always equal to 1. Next, we have the log of 64 to the base of 2 is equal to 6. So our number in here is 64. You write down 64, which is equal to our base, that is 2. Then we have our exponent, which is x. So 2 raised to 6, or 2 times 2 times 2 times 2 times 2 times 2, that is just equal to 64. We have another example. X is equal to the log of t to the base of c. Our number here is t. This is beside the log, so you write down t is just equal to our base, which is c, that is the subscript, and we have our exponent x. So t is equal to c squared is the exponential form of the logarithmic form x is equal to the log of t to the base c. Now the logarithm is the exponent. Now we have to evaluate. We have here a few examples. No, we will be evaluating this logarithmic forms or logarithmic expression. On the second column, we have our guide questions as to how we will evaluate this. And on the third column, we have here the logarithm or the logarithmic expression evaluated. So number one, we have the log of 2 to the base 2. What is our base? That is 2. So you think of the power of our base 2 that will give us the number 2. And that is only 1, right? The exponent or the power of 2 to have 2 is just equal to 1 since 2 raised to 1 is just equal to 2. Therefore, the log of 2 to the base 2 is just equal to 1. Next, we have the log of 32 to the base 2. Our base is 2. So you think of the exponent or the power of the base 2 to have an answer of 32. 2 to what power gives 32? That is 6. Since 2 raised to 6 is just equal to 32. Hence, the log of 32 to the base 2 is just equal to 6. Next, we have log of 64 to the base 4. Our base is 4. So 4 to what power gives 64? That is 3. Since 4 cubed or 4 raised to 3 is just equal to 64. Hence, we can say that the log of 64 to the base 4 is just equal to 3. Next, we have the log of 5 to the base of 25. So our base is 25 in here. Now, 25 to what power gives 5? That is 1 half. Since 25 raised to 1 half is just equal to 25. If you are to convert 25 raised to 1 half into a radical form, that is just the square root of 25, and the square root of 25 is just equal to 5. Hence, the log of 25 of 5 rather to the base 25 is just equal to 1 half. Next, we have the log of 1 to the base 7. Our base is 7. Now, 7 to what power gives 1? That is 0. Since 7 raised to 0 is just equal to 1. Hence, the log of 1 to the base 7 is just equal to 0. Next, we have another example. We have the log of 9 to the base 9. Our base is 9 in here. So 9 to what power gives us the number 9? That is simply 1 since 9 raised to 1 is just equal to 9. Thus, the log of 9 to the base 9 is just equal to 1. So that is how you are to evaluate a logarithmic expression. Now we have here the laws of logarithm. Let b be a positive number not equal to 1. Let x and y be any positive number and n be any real number. Then we have law number 1. If you have here the log of x times y to the base b, that's just the same with log of x to the base b plus log of y to the base b. So you are just expanding this form. And this is what we call the logarithm of a product. If ever you will see a product of logarithm of a product, so all you have to do is to expand that one and use the addition operation. Next, we have if you have here the log of x, the log of x over y to the base b, or the log of the quotient of x and y to the base b, is just equal to the log of x to the base b minus the log of y to the base b. And that is what we call the logarithm of a quotient. So if ever you will be seeing a logarithmic form using the quotient form, then you will be expanding that one using the subtraction operation. Next, we have law number 3. That's the log of x raised to n, or the log of x to the power of n to the base b, is just equal to n times the log of x to the base b. So what you did is you just move the exponent before or beside the logarithmic symbol, and that is what we called on the logarithm of a power. Now, to further understand that one, we have here a few examples. We will use the laws of logarithm to expand each term, but let us go back to the laws first. Law number 1, that's logarithm of a product. Number 2, that's logarithm of a quotient. Number 3, that's logarithm of a power. Okay, let's try to solve number 1. That's the log of 7 times 5 to the base 2. So this has the operation multiplication. That means we will be expanding this one using the form of addition. All you have to do is to copy the log of our first term, that is 7. We have the base 2, and then you change the operation into addition. Next, you have in here, you write down log, then at the other number, that is 5, you copy the base 2. So that is how you will expand it. We have applied law number 1, or the law of the logarithm of a product. So if ever you will be seeing this one, this is just how you will do it. Next, we have another example. This is still of the form of the logarithm of a product. So we will just expand this one using addition. Okay, you write down the log, our first term, that is 7, plus another log, our second term, that is x. Still, we have applied law number 1, which is the logarithm of a product. Next, we have the logarithm of a quotient. So when it is a quotient, you have to expand that one and use subtraction. Okay, first you write down log, and then the upper one, the numerator, that is 8. Copy the base 5 minus. You write down again log, and then the denominator, which is x, copy the base 5. So easy as that. When you expand the log of 8 over x to the base 5, that is just equal to the log of 8 to the base 5 minus the log of x to the base 5. And this is what law? This is law number 2, the logarithm of a quotient. Next, we have the log of e squared to the log of e squared over 4. Okay, so to do that, we have to use the subtraction property, subtraction operation. So you have in here the log of e squared minus the log of 4. Now, are we gonna stop in here? So we just simply applied law number 2, no? So are we gonna stop in here? Not yet, because we still have in here e squared, which is of the form, which can be done, which can be simplified using our law number 3, the logarithm of a power. So what will happen? The exponent in here will be moved before your log, and then you copy e minus, you copy the log of 4. So our final answer would be 2 log of e minus log of 4, and that is applied, or that is done using our third law. Next, we have the log of 9 cubed to the base 4. Let me just put an arrow in here. Okay, so the log of 9 cubed to the base 4, what can we apply? We can apply law number 3, the logarithm of a power. So the exponent 3 in here will be placed before the log, okay, before the log, and you write down the number 9, you copy the base number 4. So 3 times the log of 9 to the base of 4, or 3 log of 9 to the base of 4. And this is our final answer using the third law, or the logarithm of a power. Next, we have number 7. So I will be putting here an arrow. This is the log of x times the cube root of y to the base b. So this is multiplication. So we will apply first the law of product. Okay, we will apply first the law of product. This becomes the log of x to the base of b plus the log of cube root of y to the base of b. You put that equal sign in here. Now, the log of x to the base b is already in simplified form, so all you have to do is to copy that one, the log of x to the base b, plus the log of cube root of y to the base b. This can still be simplified. Remember, when this is in a radical form, you have to convert this one into its exponential form. Now, the cube root of y is just equal to y raised to 1 over 3. So that means we have the log of y raised to 1 over 3 to the base b. But we won't be stopping in there because this can still be simplified using our logarithm of a product. So what will happen is you copy the log of x to the base b plus you have in here your exponent will be placed before the symbol log. So this becomes 1/3 times the log of y to the base b. And that will be our final answer. Okay, next we have number 8. So where will I put number 8? Let's have it in here. It cannot be seen. I will be using a blue. Okay, number 8. So we have the log of the fourth root of x all over 36y to the fourth power. Okay, so this is in the quotient form. This is a logarithm of a quotient. Okay, the logarithm of a quotient. So we will be using the operation subtraction. This becomes the log of the fourth root of x minus the log of 36 y to the fourth power. Do not forget the base 5. So copy the base 5 in here. Okay, next we have in here a radical sign. So we need to convert this radical form into an exponential form. Now this becomes the log of x raised to 1/4 to the base 5 minus the log of, we have in here, well, the log of 36y to the fourth power to the base of 5. Now, we already have it in here, but take note, this is a product. So we can still expand this one using the operation addition. We have here the log of x to 1/4 to the base of 5 minus, we have here the log, okay, let's put a parenthesis in here, the log of 36 to the base of 5 plus the log of y, okay, the log of, for a while, the log of y to the fourth power to the base of 5. But then again, we can still simplify this one. We can apply the third law, which is the logarithm of a power. So from log of x to 1/4 to the base of 5, the exponent in here will be placed before the logarithmic symbol. So that becomes 1/4 times the log of x to the base of 5 minus, we have in here our log, okay, log of 36 to the base of 5 plus, and we still have another in here. We can still apply the third law or the logarithm of a power, wherein the exponent or the power of 4 in here will be placed beside the logarithm. So this becomes 4 times the log of y to the base of 5. And this will be our final answer. So that is how you will apply these concepts. Okay?